You just finished a long run, you got all your data acquired, but what's the next step? There's one important step before you go searching for that lost dongle.
Hey everyone, and welcome back to another Cytobytes tutorial. Today we're diving into a crucial aspect of cytometry data analysis that sometimes gets overlooked: quality control. Now let's talk about why you should care and how to address it. Now if you've ever worked with cytometry data, you know that it can be messy. During sample acquisition, various technical issues can creep in, leading to erroneous events that can really throw off your downstream analysis and even lead to false discoveries. Have you ever seen a sudden, abrupt signal changes in your data? Could be due to a clog in the system. Maybe you've noticed gradual increases or decreases in signal integrity at the beginning of your run. Could be the instrument warming up and changing. Changes in the speed at which your sample is being acquired can also cause signal shifts that persist throughout a portion of your data. Manually identifying and removing these problematic events can be incredibly time-consuming and subjective. Not to mention, not great for reproducibility. There are a few really cool automated tools for cleaning up your flow data. You might have heard of a few: Flow AI, Flow Clean, Flow Cut. But I'm going to be showing you one of my faves, PeacoQ, or Peak Extraction and Cleaning Oriented Quality Control. I like it because it scales really well when you have a large experiment with lots of SES files. It also has a high median balance accuracy and works on Cytoph and spectral data, not just traditional flow. It uses a clever approach based on density peaks within your data. Once those peaks are isolated, the cleaning strategy begins with two main filtering approaches. The first is an isolation tree. Imagine building a decision tree that tries to isolate individual data points based on their peak values. PeacoQ uses a special kind of tree called isolation tree. It effectively identifies bins with aberrant peak values that are easily separated from the rest of your data. This is particularly useful for catching those sudden shifts or unusual patterns that might affect multiple markers simultaneously. Unlike other methods, PeacoQ's isolation tree approach can identify and remove non-consecutive regions of bad data. For example, if you had a couple of short clogging events separated by good data. The second step is a median absolute deviation distance. For more subtle changes that might not be picked up by the isolation tree, PeacoQ looks at each marker individually. It smooths the peak values over time and then calculates how far each of the bin's smooth peak value is from the median of all the other smooth values for that marker. If a bin's peak value deviates too much, by default it's set to 6 median absolute deviations, it's flagged as a low quality. This helps catch issues where only a specific marker is affected. And finally, PeacoQ performs a couple important quick checks. It warns you if any of your markers show a consistently increasing or decreasing signal over time. This could indicate a problem like contamination. And while PeacoQ doesn't automatically remove all the data in this case, as the issue isn't localized, it alerts you to the potential problem. It also warns you if it ends up removing more than 70% of your total data. This could be a sign of a really poor quality sample, or you might need to adjust the algorithm's parameters. So, with that all said, let's grab your coffee, and we'll jump right in on how to use PeacoQ. Coffee, the official sponsor of, what does that do again? I'm going to show you the easy way and the free way to do it, and that means using R. It's really simple, but I can understand if it's your first time doing it, it might seem a little intimidating. But I promise by the end you'll be fine. All the links and any code you find in this video, see in the description. To start, if you don't already have R installed, you'll need to go download it. If you're Windows, you'll want to make sure you grab R tools too. And while technically not necessary, if you're new to R, I recommend using an IDE like RStudio, which is what we'll use in this video. Alright, once we're in, we'll make sure you have Bioconductor installed. This little line here just to check to see if it's already there. If you don't, it'll install it. Then we'll install PeacoQ from Bioconductor with this line. We'll be using some other tools from the Flowcore package, but you don't have to worry about installing that. PeacoQ installs it for you, so don't stress about that if you see some Flowcore functions coming up. Then we'll load in our FCS file or files. Then we'll just select the channels that we want to do quality control for. We're going to be removing marginal events first before applying the compensation. We do that with this little line here from Flowcore. Then we'll apply the compensation. If you're using your machine's comp that came off your flow cytometer, it'll be stored in the spill channel. Then we can transform the flow data. Now we can start with PeacoQ. But if you're starting with Peacock for some other method through a plugin for another piece of software, just remember Peacock is expecting your data to be both compensated and transformed for traditional flow cytometry data. If you're doing spectral data, you'll just need to unmix. And if you're using Cytoff, then transform. Now this will create a new object to store the clean data by running the Peacock function. You just give it the flow object, the channels to clean, tell it to save the new files, and create plots. And then set an output directory. And that's it. It's really that easy. You can either grab the filtered flow frame from the Peacock object, or just reload the clean FCS that you saved, if you had like thousands of them. So you did it, quick and easy. Now you can progress either in R or your favorite other analysis software with the cleaned FCS files. I'll put some links in the description for the video for the package and vignette for Peacock for a little extra nuance and troubleshooting. Until next time, keep your experiments flowing, and we'll see you on the next run.